I am sorry, ladies and gentlemen, I had a malfunction on that last video, so I had to stop it. But let's take a look at the core skill on page 64. Use counting techniques. In more complex situations, you may want to use the fundamental counting principle. This involves multiplying to find the total number of possible outcomes. So if there are little n outcomes for event big N and little m choices for event big M, then there are n times m outcomes for the event where both big N and big M occur. This can be generalized to more than two events. That sounds horrendous, but it isn't. Just hang on with me. It'll be okay. For example, the choices at a frozen yogurt shop are shown below. Customers must select a yogurt type, one fruit, and one syrup. How many possible mixtures of yogurt, fruit, and syrup can the shop advertise? Well, let's count the types of yogurt that you can choose. So you have vanilla, chocolate, coffee, and peach. There are 4 types of yogurt. How many types of fruit can you choose? We have cherries, blueberries, pineapples, mango, and strawberries. That's 5. And then the type of syrup that you can choose, there are 4. Caramel, marshmallow, hot fudge, and peanut butter. To get the number of choices, you just multiply 4 times 5 times 4. So 4 5s are 20, and 20 times 4 is 80. So you have 80 possible combinations. I don't know if they still advertise or not, but Sonic used to advertise that they had over 1 million drink combinations, and this is how they found it. They took all of the different options they have and they multiplied to get the number of combinations. So all of that seeming mumbo jumbo that we read comes down to just multiplying. And that will tell you, if you are combining things, how many possible combinations you have. Now, can you imagine drawing the tree diagram for that one? Where in the first column we would list all the yogurt choices. And then you would have to list all the yogurt with the fruits. And then the yogurt and the fruit with the syrup. That tree would be enormous. So this is just a much shorter way of doing that. I want to go back just a second to my tree diagram because I want to show you what's happening here. The same principle will work here. On the first toss, you have 2 possible outcomes. On the second toss, you still have 2 possible outcomes. And on the third toss, you have 2 possible outcomes, heads or tails. If you multiply these, how many combinations would you get? So 4 times 2 is 8 possible outcomes or combinations. And sure enough, that's what we got with the tree diagram. So if you're on a test and you have to find an answer, you're probably going to get there much faster to do it with just math instead of drawing the table or the tree. But it's the same type of thinking that we're looking at. Okay, let's take a look at the bottom of page 64 and talk about permutations. Permutation. Permutation. And I'm going to give you a definition if I can find one that makes sense. Okay, this is a good definition. a selection of objects or values in which order is important. One of the best illustrations of this is a race. Whether it's a foot race, a horse race, a car race, where order matters. The person who finishes first in the Kentucky Derby wins $1 million. The person who finishes second wins maybe 200,000. So order is important in that situation. And so a permutation helps you to understand that particular situation. And there are 3 variables that you need to know to work with permutations. So let's draw a variable box, just like we did with interest, rate, time, all that good stuff. So we have capital P, we have little n, and little k. Okay? So P stands for the number of permutations or possible finishes. N stands for the number of items. I didn't draw my table big enough, did I? Number of items. So if there are 12 horses in the Kentucky Derby, N would be 12. And then K is the number of items being ordered. So if we're looking at the top 3 finishes, we would have K equaling 3. Now we're going to practice this. And you know what I didn't do is the think about math section right in the middle of this page. I just skipped right over that. So we'll go back to that, but let's go ahead and finish this train of thought while we have it. So here's the formula, and it's scary looking, but don't be alarmed. It's okay. P times N times K, or P of NK, equals N factorial over N minus K in parentheses factorial. All right. So let's look at an example here. There are 3 people. Let's not do that. Well, let's use the example that's in the book because I don't want to get you confused. There are 10 competitors in a math competition. So 10 high school students go to a math competition. But only the top 3 get a prize. So that means 7 of these folks are going to walk away with nothing. You have to finish in the top 3 to get the prize. How many different ways could the competitors finish in first, second, and third place? So how many ways could they finish? This is a permutation because the order matters. In order to get a prize, you have to finish in one of the top 3 seats. And that's what makes it a permutation. So let's assign some variables here. 10 competitors. Would that be P, N, or K? That's going to be N, because this is the number of people competing in this competition. K is the number of items ordered. It's only the 3 at the top that matter. So that is K. K is 3. Let me do it this way. N is 10. K is 3. And then P will be the number of ways to finish. And that is the unknown thing. P is what we're looking for. So our formula will look like this. P, which we do not know yet, but we know N is 10, and we know K is 3. So we can fill in our formula here. Now I'm going to set it up so you can follow me just a little bit easier. All right, N is 10. So I'm going to put a 10 right there. Then N minus K goes down there. So 10 minus 3, that's going to be 7 factorial. So this becomes the 7. Put that in your calculator. Where's my calculator? You could do it longhand. I've done it many times. So on the top, you would be saying 10 times 9 times 8 times 7. That's going to take all day. So let's just put it in the calculator as all clear. 10 shift 3 equals. Now don't panic. It's big. These are going to be big because they're factorials. 3628800. Just write it down. All clear. 7 shift 3 equals 5040. Now, let's all clear. 3628800 divide 5040 equals 720. So there are 720 permutations or ways that these students could finish. So P is 720. Now there has to be a way that this calculator will do permutations. But rather than have you, I think I see it actually. Hold on one second. Shift 10, 3 equal. No, I'm going to have to research that, and then I'll come back in the next video and show you how to do that. I'm going to stop this video and record the Think About Math so that for you it will be in the proper order. So I'm going to go back right now and get that, and then we'll continue with permutations.